Hi guys, welcome to Code Bashers. So guys, as you all know that TCS NQT exams are starting from next week. So in this particular video, I will be discussing the previously asked actual coding questions which have been asked in TCS NQT. Guys, the best way to prepare for any exam is by solving the previously asked questions. So total two coding questions I will be discussing in this video. Make sure to watch this video till the end. And if you want to know more that how you can practice previously asked questions of different sections of TCS, that also I will be telling you in this particular video. So don't skip any part of this video. Make sure to watch this video till the end. And guys, we are continuously making videos for different companies preparation. Okay, we have made Accenture, Cognizant, Infosys, and now we are making videos for TCS. So make sure to hit that like and subscribe button for this channel, because every like and subscribe motivates us for making more such videos. Okay, if you have any doubts, you can write in the comment section, or you can join this Telegram group. It's dedicated for 2026 batch students. All the relevant links you will find in the description box. So now let's start this video.
Okay, so guys, first of all, we will be discussing the question, then the approach of this question, and finally, we will be discussing the code part of this question. Okay, so let's just read the question first. So, given an array of integers, find an index such that the sum of elements at the lower indexes is equivalent to the sum of the elements at the higher indexes. If no such index exists, return -1. So, let's just understand this question with the help of example. So for example, this is our array given, that is -7, 1, 5, 2, -4, 3, 0. This is our input array. Index 3 is an equilibrium index because we need to find the equilibrium index. Now it is saying that index 3 is the equilibrium index. This is index 3. So how it is the equilibrium index? So what is an equilibrium index? If at that index the sum of the elements on the left side is equivalent to the sum of the elements of the right side. So this is the equilibrium index. So what is the sum of what are the elements at the left side of this index? So these are the elements at the left side of the index, and these are the elements at the right side of this index. So what is the sum of these elements on the left? So it is -7 plus 1 plus 5. So it is -1. So all the elements to the left of this index has some -1. Similarly, all the elements on the right side of this index has some -4 plus 3 plus 0. This is -1. So if you can see here that this at this index 3 index, all the elements on the left side of this index have -1 sum, and all the elements at the right side of this index has -1. So it means the sum of the left elements are equivalent to the sum of the right elements. Therefore this third index is the what you will say equilibrium index. Okay, so this is how an equilibrium index is defined. So in this case, the equilibrium index was present. Okay, so therefore we have printed the 3 is the equilibrium index because this is third index. So 0, 1, 2, 3. So this is the third index. But there might be some arrays in which there is no equilibrium index present. Okay, so in that cases we need to return -1. In that cases we need to return -1. Okay, so I hope now the question is clear to you. This question is slightly on the easier side. So let's just see the approach of this question. And if you are finding this video helpful, or you have any doubts, you can always write in the comment section that yes, this video was helpful, or you have this doubt. Okay, so this all gives us motivation for making such videos. Okay, so now let's just move towards the approach part.
Okay, so guys, before moving ahead in the video, I would like you to know that on our top mid page of Code Bashers, we have TCS NQT exam preparation material. So all the sections that will be asked in your TCS NQT exam, we have the previously asked actual questions in this particular material, whether it is verbal ability, numerical and advanced quantitative, reasoning and advanced coding questions. All the previously asked questions are covered here. If I will show you the sample of, let's suppose, the reasoning PDF, so you will see we have the proper question, proper option, and the correct answer for it. Similarly, in the numerical also we have the proper question, the proper options, and the correct answer for it. The best way to prepare for any exam is by solving the previously asked questions. So now you have time of at least, I would say, 3 to 4 weeks before your TCS NQT exam starts. So best time is to start preparing now only. Okay, and for the first 100 students, we have a flat 20% discount on this preparation material. The coupon code I will give you in the description box. Do check that out. Okay, and the link of this material also you will find in the pinned comment. So now let's continue with the video.
Okay, so now let's just see the approach of this question, how we will do it. So this is our input array that is given to us, -7, 1, 5, 2, -4, 3, 0. We need to find the equilibrium index. And what is equilibrium index? Equilibrium index is nothing but the sum of the elements to the left of those index is equal to sum of the elements to the right of those index. Okay, if that is the case, then it is an equilibrium index. So what we'll do in this approach, we will form two arrays. One array will contain left sum, next array will contain right sum. So you will be confused at what this left sum array will do. So let's just see. So see, while we are iterating this array, first of all, we will be filling the left sum array and then we will be filling the right sum array. Okay. So we have, once we are iterating this array, that is -1 1 5 2. Okay. So for left sum we will be iterating from left to right, and for right sum we will be iterating from right to left, this array. So let's just fill the left sum array first. Okay. So -7, so we are at this index, that is we are at the current index -7. Now what is the sum of the elements to the left of this 7 -7? So since it is the first element, so the sum of the elements to the left of this element is 0. Okay. So we will place 0 here. Now we are coming to the next index, that is 1. Okay, that is 1. So what is the sum of the elements to the left of this 1? Okay, to the left of this 1. This is -7. Because we won't include that particular element in the sum. We only want the sum of the elements towards the left of that element. So the sum of the elements to the left of this 1 is only -7. So therefore we have placed -7 here. Now we are at 5. Okay, we are at 5. Now what is the sum of the elements to the left of this 5? It is -7 plus 1, that is -6, right? I hope you are with me. And how we are calculating this sum? Because every time whenever we are at index, we do not need to again go back and calculate the sum of all the elements. We can maintain a variable, that is sum left. Okay, sum left we can maintain. So this is a variable. Initially it will be 0. So 0, then it will be -7. It will, like, whenever we are processing an index, we can always add the value to this particular variable. So let's just start over. I hope the idea is clear to you. Let's just quickly start over so that you know that how to do it. So currently, once we are iterating the array, we are at -7. So sum left will be 0. So we have placed 0 here. Now we are at next index, that is this one element. At one element we are there. So what we'll do sum left -7 here. So it will contain now -7. Okay, it will contain -7. We are at 1, so it will do -7. So after, before moving to the next index, we will add this one to the sum, so it will become -6. Okay, so we will add -6 here. Now before moving to next element, we will add +5 to it. So after it, it will become -1. So at this 2, this sum left will contain -1. Now we are at -4. Now before moving to -4, we will add 2 to it. So -1 plus 2 equivalent to 1. So we have 1 here. Now before moving to 3, we will add -4. Okay, so 1 minus 4 is, this all is contained in this sum left variable. So 1 minus 4 is -3. Okay, so -3 it is there. So till here it is -3. Now again we will add, what we'll do, before moving to 0, we will add this 3 to it. So -3 plus 3, it becomes 0. So we have added 0 here. Oh yes. So so this index in the sum left represents the sum of the elements to the left of current index. So if we are talking about this 0, so all the elements before it has some 0 only. So -7 plus 1 -6, -6 plus 5 is -1, -1 plus 2 is 1, 1 minus 4 is -3, -3 plus 3 is 0. So therefore this value represents the sum of the elements to the left of this element. Okay, so I hope this is clear to you, the left sum. Similarly, we will do with right sum, just one difference, that in right sum what we'll do, we will traversing from right to left, from backwards we will start like this. So again we will take any variable, right, left. Okay, initially it will be 0. So we know that uh, it will contain, if we are at current element, it will contain the sum of the elements to the right of that element. So if it is the last element, of course it will be 0. So right left will be 0. So here we will place 0. Now before moving to 3, what we'll do, we will add this 0 to this right left. So 0 plus 0 is 0 only. So again, to sum of the elements to the right of 3 is 0. Okay, now again before moving to -4, what we'll do, we will add this 3 to this right left. So we will do +3 equivalent to 3. So it is 3. Now again moving towards 2, what we'll do, we will do 3, we will add this -4 to this right left. So 3 minus 4 is -1. So we will do -1 here. Okay, now again going to 5, again before going to 5, we will add this 2 to -1. So it will become -1 plus 2 will become 1. Okay, so it will become 1 here. Okay, again before going to 1, we will add this 5 to it. So 1 plus 5 will become 6. 1 plus 5 will become 6 here. Okay, so again going to -7, we will add 6 minus 7 minus 1. So 6 minus 7 equivalent to -1 here. So we will add -1 here. But I have done mistake in the last element only. So 6 plus 1. 6 plus 1 we need to do. Sorry. Okay, 7 it will be. In the last element I made the mistake. Now what we'll do, we have now left some arrays and right some arrays. We will do nothing. We will iterate over the array from 0 to 9, 0 to n, we will iterate. And at any index, at any index, once we have found that, okay, the sum at that index in the left sum array and the sum at that index in the right sum array are equal, then we will say that that index is the equilibrium index. So in this case, you can see that -1 and -1 are at same position, and 0 and 0 are also at same position. But since we are traversing from left to right in this particular case, first minus one will be first equilibrium index will be treated. In this case, it is third index. We'll simply print out I. So this was the entire approach. I hope the approach is clear to you. Okay, now let's just move towards the code part. Okay, so guys, for saving time, I have already written the code, and let's just read line by line what this particular code is doing. So we will first input n, that is what is the length of the array, input array. Then we will declare the arrays. First is the input arrays, next one is the left sum array, next is right sum array, and we have declared the index. Okay, because if no equilibrium index is found, we need to return -1. Therefore, we have initialized this equilibrium index variable as -1. So this for loop is for taking the input in the array. Okay, then we will first fill the left sum array, as I have told you. That is, left sum at the current element denotes the sum of the elements to the left of that particular element, but that particular element is not included in that sum. Okay, remember that. So we have taken a variable called left. It will contain the left sum of the current element. So this is the loop for filling out the left sum array. Okay, so initially what we'll do, we will do left sum of current I equivalent to the left till now the left value. So initially at first location, we know that the element that is present in the first position, its left sum is already 0. So therefore initially we have done left sum of I equivalent to left. And again, before going to the next position, we are adding current element to this left sum. As I've told you that before going to the next position, that particular value will be added in the left sum variable. Okay, in the left sum variable, and this will continue and it will fill the left sum array. Similar case we need to do with the right sum array. Again, we have taken the right variable, it will contain 0. We are iterating from back to starting, reverse we are iterating, that is last element first and then the first element. Okay, now again, we know that the right sum of the last element, the elements that are present, the right elements of the last element of the array are 0 only. There are no right elements to the last element. Therefore, initially only we have done right sum of I equivalent to right, so that 0 will go there. And then again, before moving to the next position, like this particular value will be added first. Okay, this particular value will be added. So I hope I have made my point, and this is how the right sum array is filling. Then what we'll do, we will iterate from 0 to n, because these are the number of this is the length of the array. And at any position, we will check if the left sum of that index is equivalent to the right sum of that index. If that is equal, we have found the equilibrium index. We will just set the value of index variable to that particular index, and then we will break from here, because there might be possibility that there are 2 or 3 equilibrium index present in the array, but we are only worried about the first index, that is equilibrium index. So therefore, once we have found it, we will be breaking it, and in the end we will be simply doing cout equi index. There might be a case where there are no equilibrium index present, so there, in that case, since we have initialized this equi index with -1, therefore this variable -1 will be printed, okay, with no changes. Now let's just run our code. So this was our input, 7 -7 152 -430. So in this case, our equilibrium index should come out to be as 3. Okay, so you can see 3 is coming. Let's just see a case wherein the equilibrium index should be coming out as 1. Oh, sorry, -1. So 1 2 3 4. So in this case, if you will check 3, okay, in this case also no. So let's just do it 4, and let's just do it 5. Okay, so these are 4 elements. In this case, -1 should be coming as the equilibrium index, because no, okay, you can see -1 is coming. So this particular code will pass all the test cases that will be given to you. You can always take the screenshot of this code. Okay, I have explained line by line. If you still have any doubts or you want some more questions, you can always add in the comment section.
Okay, so guys, before moving ahead in the video, I would like you to know that on our top mid page of code bashers, we have TCS NQT exam preparation material. So all the sections that will be asked in your TCS NQT exam, we have the previously asked actual questions in this particular material, whether it is verbal ability, numerical and advanced quantitative, reasoning and advanced coding questions, all the previously asked questions are covered here. If I will show you the sample of, let's suppose, the reasoning PDF, so you will see we have the proper question, proper option and the correct answer for it. Similarly, in the numerical also we have the proper question, the proper options and the correct answer for it. The best way to prepare for any exam is by solving the previously asked questions. So now you have time of at least, I would say, 3 to 4 weeks before your TCS NQT exam starts. So best time is to start preparing now only. Okay, and for the first 100 students we have a flat 20% discount on this preparation material. The coupon code I will give you in the description box. Do check that out. Okay, and the link of this material also you will find in the pinned comment. So now let's continue with the video.
Okay, the chocolate packets are represented an array of n numbers of integer values. Okay, the task is to find the empty packet of chocolate and push it to the end of the conveyor belt. So let's just simply understand with the help of the example. So it is nothing, just that we are given an array. Okay, so we are given arrays and each element represents the number of chocolates in that particular packet. Okay, so here inside this packet there are 4 chocolates, inside this packet there are 5 chocolates, and inside this there are 0 packets. So what this question is saying, this question is saying that okay, you can see that there are some packets with 0 chocolates in them. So we just have to move them to the end of the array or the end of the conveyor belt. So this packet contains non-zero number of chocolates, so it will remain like this. This packet contains non-zero chocolate, so it will remain like this. This packet contains 0 chocolate, so it will be moved at the last of the array. So this is the input that is given to us, and this is the output that is expected. That is, all the zeros have been moved towards the end of the array. And if you will look closely, you will see that the relative order of all the packets are same. That is 4, 5, 1, 9, 5. So here also 4, 5, 1, 9, 5. So relative order will remain same of the packets which are containing chocolates, and all the packets with zero number of chocolates will be moved towards the end of the array. So this is the question that we need to do. Okay, so let's just see with the help of example, next example also. So here there are 2 packets initially which are having 0 chocolates. Okay, and then there are 4 packets which are having non-zero chocolates, that is 1, 2, 4, 5. So in this, what will happen, so all these packets with no chocolates will come in front. Okay, will come in front with the relative order same, and those packets which are having chocolates at 0 will be moved towards the last of the array, and this is how our output will look like. But two things to notice, just that all the zeros should be moved towards the end of the array, and the um, relative positions of all the non-zero elements should be same. That is, in input 1, 2, 4, 5 are coming in the same sequence, in the output also 1, 2, 4, 5 should come. Similarly, here in the input sequence there is 4, 5, 1, 9, 5, and in the output also there is 4, 5, 1, 9, 5. So relative order should be kept same for the packets. Okay, and all the zeros should be moved towards the end of the array. So now let's just discuss the approach of this particular question. Okay, so guys, the approach is very simple. Sorry, yes. So the approach is very simple. What we'll do, we'll be using the two-pointer approach. So here is our input array, that is 0, 0, 1, 2, 4, 5, and we know the output is all the zeros should move towards the end of the array, and relative order of all non-zero elements should remain same. So output will be 1, 2, 4, 5, and then two zeros. Okay. So what we'll do, we will take two pointers I and j. I will be for iterating the array and j for marking zero positions. Okay, so here we have taken two pointers. Initially, they will be pointing to the first element. Okay, first element of the array only. Why I is used? I is used to iterate the array. Okay, I is used to iterate the array, and j is used to mark the position of zero, because we need to swap the element, because zero needs to move towards the end. So we need to know that at which position zero is there, and at which position non-zero elements are there. So I will be for iterating the array and j will be for marking the zero positions. Okay, now if the ARR of I, that is, the I was for the iteration of the array, so if the current element is 0, then we will do nothing, simply move I to the next position. Okay, if the current element is not equivalent to 0, then swap error of I with error of j. Why we are swapping? Because error of j, we will have the position of 0, we will have the position of the 0 element. Okay, so we will swap ARR of I with ARR of j and move both the I and j to the next position. So I know by reading this approach, you will not be understanding anything. Let's just like dry run this particular code. So currently what we are at where we are. So we are at 0 position. So I was used to iterate the array. So if ARR of I is 0, then do nothing. So currently ARR of I is equal to 0. So we'll do nothing. We will simply move I to the next position. Okay. Now again we will check. Now we are at next position. So next iteration is there. So again we are ARR of I is again 0. So we'll do nothing. We will move I to the next position. Okay. So I will go here. Now again we will check. So again we find this now that ARR of I is not equivalent to 0. So this condition is fulfilled. Fourth one. Then what we'll do? We will swap ARR of I with ARR of j and move both I and j to the next position. So what we'll do? We will be swapping ARR of I with ARR of j. So now this will become 1 and this will become, but this will become 0. And after this what we'll do? We will move j to the next position and I to the next position. Okay. Now again we'll check ARR of I not equivalent to 0. Okay, ARR of I is not equivalent to 0. So again we'll swap ARR of I with ARR of j and we'll move j and I both to the next position. So again here we will swap. So 2 and then here also it will be 0. And again we will move I to the next position and j to the next position. Okay, again we'll check for error of I. Again error of I is not equivalent to 0, it is 4. So again we'll swap those values. So here it 4 will come, here 0 will come, and we'll move towards the next position. I also to the next position. Okay, now again we'll check error of I. Again error of I is 5, so it means it is not equal to 0. So again we'll swap the elements. So it will become 5 here and 0 here, and we'll move I and j to the next position. Okay, I and j to the next position. So after doing this I comes outside the loop, it means the iteration is over, and you will see now that okay, all the 0 elements have moved towards the end of the array and all the non-zero elements with their relative position intact are at the starting of the array. So this is the entire approach. It is very simple. You just have to take two cases. If the current element is 0, then what to do? If the current element is not 0, then what to do? So this is the simple case in which we can do this. So I hope now the question and approach is clear to you. And if you are finding this video very useful, then please hit that like button as well as subscribe button, because these things motivate us for making more such videos. So now let us quickly move towards the editor and write the code for it. Okay, so guys, for saving time, as you all know, I've already written the code. Let's just go line by line to see what that code is. Okay, so first of all, we have taken n as input, that is the length of the array. Then we have taken all the elements of the array as input. Okay, then I've told you we will be taking two variables, j is equal j and I. So I will be for iterating over the array, and j will be denoting the latest position of 0 element. Okay, so both will be starting with 0 only, that is 0 index only. So j equal to 0 and I is also equivalent to 0. Now, while creating the array, I have told you there are two conditions possible. That is, if the current element is 0, then what to do? If the current element is not equivalent to 0, then what to do? So it was simple that if the current element is 0, then we had to do nothing. Okay, we just have to do I plus plus that this loop is doing automatically. So that condition is handled automatically. Now the condition was if the current element is not equivalent to 0. So if the current element is not equivalent to 0, what I told you to swap the values of error of I and error of j. I have told you by dry running it what will happen, and then what we'll do, we will do both I plus plus and j plus plus. So j plus plus we will have to do manually, but I plus plus again it will be handled by this loop only. For next iteration it will automatically go to the next I position. Okay, so this was the case. If the current element was 0, no need to do anything. If the current element is not equivalent to 0, then swap the values of error of I and error of j and do j plus plus. Okay, and now see one more thing. We are using this library, that is hash include bits slash stdc plus plus dot h. It contains all the inbuilt functions and all the like stack queues as well as the swap method. So this is an inbuilt method. You don't need to go and write the swap function for it. So this is the inbuilt method. Okay, so for using this inbuilt method, you just have to include this particular library. Okay, and you will be able to use it. So once this loop is over, we know that all the zeros have been moved towards the end of the array and all the non-zero elements with their relative positions are in the front of the array. So using this for loop, we are simply printing the array, printing the required array once all the swapping has happened. So let's just quickly run this code and let's just see if it is working fine or not. So we have taken our example here. So 8 elements are there, 4501950. So it should give us that all the non-zero elements with their relative position are in the front. So all the Non-zero elements with their relative position are in front and all the zeros are at end. Let's just take one more example here. So let's just give it 6 and let's just give it, okay, 0 0 1 2 3 4. So 1 2 3 4 should come at front and 0 0 should go at the last. So let's just see if it gives the correct answer or not. So yes, the answer is correct. So this particular code will pass all the test cases that will be given to you.